Hello, am I audible? Hello, am I audible? Okay. Okay. Today we are going to learn about polynomials. Right? Before entering this topic, we have to discuss about some important things like what is constants and what is variable. Constants means a fixed value. Okay. Like 9 or -6, or if I take any real field, then it will be 3 by 2 also root over. Okay. And what is variable? A variable means a symbol by which we assign some different numerical values. Like we assign different numerical values. Like we know that the perimeter of a circle is 2 pi r. So here r is the variable. Why? Because we don't know about the radius of the circle. It may be 2 centimeter, it may be 1 meter, it may be 3.5 inches, anything. So we assign different values to this variable. Okay. So another example, like We may use x also, y also, and different English letters and also Greek letters like alpha and beta, gamma, etc. We can use as a variable. Okay. Now next topic is algebraic expression. Okay. A combination of some variables and constants separated by plus and minus. Like as example, 2x plus 3. Yes, it is a combination. Root over 3 by 5 x squared minus 7 plus x cube. Yes, it is also a combination because we combine variables, constants, and both. And the connection is just plus and minus here. This is the minus and this is the plus. Next, what is terms? In algebraic expression. Whenever we write an algebraic expression like this, as example, I took 7x plus 9 minus 5x to the power 3. So these several parts, like this is a part also, this is a part also, separated by the plus and minus, are called terms of this expression. Now take another, I am taking another example here. 4 x cube plus root 2 x square, also 5 by 9x minus 8. So of course this is an algebraic expression and there are total 4 several parts separated by the plus and minus. Okay. So there are total 4 terms. Now the main topic is what is polynomial. Now the main topic is what is polynomial. So we took an expression like a0, a1x, a2x, a3x cube plus a4 x to the power 4 and so on, like ak x to the power k and so on. So in this expression, the a0, a1, a2 are all real numbers. Real numbers. That means the above expression can be written as this: sum of ai x to the power I is 0 to infinity, where ai or all belongs to the real number set. Okay, and this I is positive integer. Okay, that means this one value, this two value, and the power of this x, that is the variables, are all positive integers. A0 x to the power 0, that means x to the power 0 means 1, we get as a0. A1 x to the power 1, now I for 2, a2 x to the power 2, now I for 3, a3 x to the power 3, and so on, and we get this above expression. Okay, in this expression, this term is called constant term, and these terms are coefficients of x1, x to the power 1, x to the power 2, x to the power 3, x to the power 4, and respectively, such as ai's for I not equals to 0 are coefficients of x to the power I. Okay, so here are some polynomial examples, right? 1 plus x plus 2x to the power 2. Yes, this can be comparable as this. How we can compare this? Okay, 1 plus 1 into x plus 2 into x square plus 0 into x to the power 3 plus 0 into x to the power 4 plus 0 into x to the power 5 and so on. So the remaining terms all are 0. So if I compare with this general expression, so we get this is a0, this is our a1, this is our a2, and this is our a3, a4, and so on. Okay, next another example is x to the power 4 minus 2x to the power 3 plus 5x plus root over 2. Root over 2. Now, is this a polynomial? Let me check first. At first, comparing with this general expression. So this is our constant term because there is no variable in this term. So at first we write this, then this variable's power is 1. So secondly we can write like this, and we arrange these terms as ascending order of the power of the variables, like 5x, then comes 2x cube plus x to the power 4. Now we compare with the general expression. So how can we compare this? A0 plus a1x plus a2x square plus a3x to the power 3 plus a4x to the power 4 plus a5x to the power 5 plus and so on. So this is our root over 2, 5x. There is no x to the power 2 term, so we write 0 into x to the power 2 minus 2 into x to the power 3 plus 1 into x to the power 4 plus 0 in the x to the power 5 and so on. Other parts are all 0. Now if we compare, so here a0 is the root 2, a1 is the root 5, a2 is the 0, a1, a3 is the minus 2. So we can write like this. Yes. Okay. So a3 is the root of minus 2, a4 is 1, and other coefficients are 0 because other terms are vanished. Now my term is, what is degree of polynomial? So degree is the highest non-zero power of the variable of the given polynomial. How does it mean? Now if you get me a polynomial like 4x plus 5x to the power 3 plus 7x to the power 10. So we can see that in these terms the highest power of the variable x is this, that is 10. So the degree of the polynomial is 10. Okay. Now my another question is to you, that is this expression as a polynomial? I will be right back after some times. So until then, you think and answer it in the comment box. I will be right back after some. Okay. So my question was, is this expression is polynomial or not? Okay. So at first write me the expression in the standard way. So here we can write like this, right? So in the previous we say then the terms I all are positive integers here. You remember? You can see here that the power of x all are positive integers. But in this expression, this minus 1 is not a positive integer, it is a negative integer. So it is not a polynomial. Now another term is, we can write a polynomial as a function like f of x. F of x means there is an expression where x variable is present, like x squared minus 4x plus 3. Is this a polynomial? Yes, of course, this is a polynomial because in this algebraic expression there is no negative integer power of x. All the powers of x are positive integer. So we can write like as a standard form, like at first we write the constant term, then we write the x term, then we write the x squared term, and then we write the other term as 0. Okay. Next, number of variables. Okay, so in a polynomial we can show two types of this kind. One is one variable, another is several variable. We shall discuss in this entire lecture about this one variable polynomial. That means there is only one variable in this polynomial, like x cube or x to the power 4 plus 7 and etc. But in several variables there may be different kinds of variable is used in a polynomial, like 4xy plus z cube. There are three types of variables, so this is a polynomial of three variables. Okay, and another example is maybe like 4y to the power 4 minus 7x plus 6 z to the power 10 into x to the power square. And this is also another example. My another question is, we write a polynomial as this expression like this. Now my question is this a polynomial? Think carefully, then we will answer it. So here, if we divide x plus 3 term by x plus 4, okay, so at first if we multiply this as 1, so this will be x plus 4, and then we subtract, so we will get minus 1. So the above expression can be written as this into this minus this. So 1 minus 1 by x plus 4. So that is 1 minus x plus 4 whole to the minus 1. So here we get a negative power. So it is not a polynomial. Our next topic is what is constant polynomial. So this is those types of polynomial where only a constant term is used. Only a constant term is used. Such as, is it a polynomial? Only 4? Yes, it is a polynomial because if we compare with the general expression like a0 plus a1x plus a2x square plus a3x to the power 3 and so on. So here we can see that the a0 term is 4 and other term all are 0. So 4 can be expressed as the general expression we have seen before. So 4 is a polynomial and 4 is just a constant term. There is nothing variable, so it is a constant polynomial. So there are another example of constant polynomial like this, like 4 by 9 or minus root over 3, also like root over 5 by 7. It could be pi, because pi is a irrational number, but it is also a constant term. It is also a real number. So next is what is linear polynomial. Quadratic polynomial and cubic polynomial and biquadratic polynomial. In the linear polynomial, those are polynomials of degree 1 only. As example, like it may be x, it may be 1 4 plus x, it may be minus root over 3 minus x. So in this algebraic expression, we can see the variable x only, okay, and with the constant term also. But this highest power of x in every expression is 1. Like here it is 1, here it is 1, here it is 1. So these all are polynomials of degree 1. So these are the examples of linear polynomial. Similarly, what is quadratic polynomial? Those polynomial of degree 2. It may be 4x to the power 4, x to the power 2, sorry, minus 7 x square, only x square, plus root over 3 minus x square, and etc. So in this expression we can see that all the power of x are 2 and this is the highest power in the expression. So these are the degree of this polynomial and all the degrees are 2. So cubic polynomials means polynomial of degree 3, like x to the power 3 also, 4x to the power 3, it may be root over 3 minus 10x to the power 3, and so on. So you can see in all the expression, the highest degree are 3, like this. Okay. And biquadratic polynomial means the polynomial of degree 4, like it may be 5x to the power 4, it may be root over 7 by 10x to the power 4, it may be 9 minus 11x to the power 4. Okay, so it may be also like 10 plus 5x square plus x to the power 4. Here we can see that the highest power of this polynomial is 4. So this is also a biquadratic polynomial. That means the degree of the polynomial matters. Okay, if the degree of a polynomial is n, so there may be variables of degree less than n also. So this does not differ any kind of. So there are some examples I am giving to you, polynomials, and please tell me everybody's degree. So please find out the all the degree of this polynomial and write down in comment. Okay, I'll be right back after some time. Okay, so let me check the answer. At first check, is this polynomial or not? Yes. So the degree of the variables are all positive integers. So there is nothing problem with. So this is polynomial. And the highest degree is 4. So the degree of this polynomial is 4. Now checkmate this first, that is this a polynomial or not. Yes, this is a polynomial because the degree of each power of x are all positive integers. So yes, this is a polynomial and the highest power is 15 here. So this is degree 15 polynomial. So let me check it first. Is this a polynomial? Yeah, all the powers are positive integers. Okay. So yes, it is also a polynomial of variable y. Here I am not taking the x variable. Okay. A polynomial may be different kind of variables. Maybe different kind of variables. So it may be x, it may be y, it may be t, it may be r also. So there is nothing problem with. So the highest power is 16. So it is a polynomial of degree 16. Okay. Now my question is, what is the polynomial of it? 15 x to the power 14 minus 9 x to the power minus 12 plus 13 root over 7 x to the power 5. So let me know that what is the degree of this polynomial. Okay, minus. So my first question is, it is a polynomial or not? Here we can see the negative power of x. So this is not a polynomial. So there is nothing to find out any positive degree or any degree of this polynomial. Okay. Next is number of terms in a polynomial. One is monomial, one is binomial, power 5 of x to the power 15, etc. We have to just take one term only, just only one term. Okay, so this is a monomial. Next, binomial. Bi means two. So we have to take just two terms polynomial, only two terms. It may be different kind of powers. So it may be 9 plus 4x also. It may be root over 5 minus x to the power 16. It may be x to the power 3 minus 7x to the power 2. Anything. So in each algebraic expression we can take only two terms, just like only two terms. So these all are binomial. Next topic is trinomial. Tri means three. So by the name we can determine that all the three terms polynomial are included in this part. So it may be x to the power 2 plus 2x minus x to the power 15, and you may write as your own examples. It's your freedom choice to make more examples like this. Just mind it, you have to take only three terms. You have to take only three terms separated by plus or minus, because each part is called is term in algebraic expression separated by plus and minus. We have learned it earlier. Next is zero polynomial. Zero polynomial means only one polynomial, that is zero. Okay. Next, another topic is what is the degree of constant polynomial? To determine the degree of a constant polynomial, we have to take a constant polynomial. So let me take first an easy constant, that is as 3. So this is a constant. Yes, this is constant. So is this a polynomial? Yes, this is a polynomial. So now you have to check what is the degree of x. So there is no x. So we can write 3 as 3 dot x to the power 0. 3 multiplied by x to the power 0. You can write 3 as like this. So here we can get a variable x, but the power is 0. So the degree is, this polynomial is 0. So my conclusion is that degree of a constant polynomial is 0. So my question is, which of the following expressions polynomial and if it is polynomial, write the degree. So the questions are x to the power 5 minus 2 x to the power 3 plus x plus root over 3. Another is x to the power minus 2 plus 2x to the power minus 1 plus 3. another is 1, another one is 1 by root over 2 x to the power 2 minus root over 2x plus 2. Another term is x to the power 4 minus x to the power 3 by 2 plus x minus 2. Okay. So here we can see that all the degrees are positive integers. There's nothing miss, it means 1. So it is also positive integer. So yes, this is polynomial and degree is the highest power of x, that is 5. Next, here we can see there is 2 negative integers as power of x. So this is not a polynomial. Okay. Next, this is a constant polynomial. Yes, this is polynomial also, because 1 we can write as it 1 into x to the power 0. Yo. So this is a polynomial. So this is a constant polynomial. So degree is 0, because you can write the 0 here also. Okay. In the next example, is this a polynomial? Yes, the power of all x are positive integers. So this is a polynomial and the highest power is 2. So degree is 2. In this expression, here the power is 3 by 2, which is not a positive integer, because 3 by 2 is a rational number, not integer. So this is not a polynomial, because we have strictly learned that in a polynomial, degree of each term, degree of each variable must be positive integer. Okay. So my next question is, in the following, which one is linear, quadratic, cubic, and biquadratic? So that means you have to check the degree of the expressions. Like if I take -7 plus x, next is x minus x cube plus x to the power 4. Next term is 1 plus x plus x to the power square. Next is only minus p. Next is minus 30. So in this polynomial, the highest power of x is 1. So this is linear. And in this expression, the highest power of x is 4. So this is what? Biquadratic. The highest power in this expression is as 2, so it is degree 2 polynomial. That is quadratic. In this polynomial, this is the variable, that is p, and the power is 1, so this is a linear. And now this is a constant polynomial. Because there is nothing variable of degree 1 in this expression. So it is just a constant term, so it is a constant polynomial. Now my next question is, what is coefficient of x square, x to the power 3 and x to the power 4 of the following? So here are some there are some. So we must make a table as it is, like here we can write x to the power 4, here we can write x to the power 3, here we can write x to the power 2. These are the coefficient table. Coefficient of x to the power 2 is 1 and rest of the coefficients are all 0. Here this is a constant polynomial, so every coefficients of x to the power 2 and x to the power 3 and x to the power 4 are all 0. Because there is no term of x to the power 2, x to the power 3, x to the power 4 in this expression. Okay, here we get two expressions like x to the power 3 and x to the power 4. So this will be 1 and 1, and there is no term of x to the power 2, so this will be 0. Okay. Next is determine the degree of polynomial. Like, what is the degree of this? So we have to split this expression like this: 4x by 2x minus 5x squared by 2x plus 6x to the power 3 by 2x. Now we have to apply the exponent rules like this: 4 by 2 x to the power 1 minus 1, and this will be 5 by 2 x to the power 2 minus 1, and that will be 6 by 2 x to the power 3 minus 1. Okay, so here we go. 4 by 2, that means, okay, let me check here. That is, this is 2, this is 3. So here we can go 2 into x to the power 0 minus 5 by 2 x to the power 1 plus 3 into x to the power 2. 2 minus 5 by 2 x to the power 1 plus. So here we can get the highest degree, that is 2. So the degree is 2. Okay, this is the ending for today. So I will be right back another day with more expressions of polynomials and putting values of polynomials and etc. So this is all about for today. Thank you.